In this section, we'll be looking at exponents and more specifically combining negative and positive exponents. Let's begin by looking at how to change from a negative exponent to a positive exponent. If you recall, any base that is raised to a negative exponent, you must take the reciprocal of that term and then make the exponent positive. So in this case, we have 1 divided by x to the negative n. So the reciprocal of that would move the term of x to the negative n into the numerator, and then the n becomes positive, leaving us with x to the positive nth. Now, in a more complex case of this, we have x to the negative m divided by y to the negative n. So we have two terms that we need to deal with first. So let's begin with the x to the negative m. If we take the reciprocal of that term would move into the denominator, and notice the m becomes positive. Now let's work with this y to the negative nth. Again, taking the reciprocal of that, it would move it into the numerator, and notice that the n becomes positive, leaving us with y to the positive n divided by x to the positive m. If we look at an example of this, again we have two terms with negative exponents, and as a thing to remember, you never want to leave your most simplified version with negative exponents, so we know we need to get rid of them. And the way we do this is by looking at each term. So we have 3 to the negative second, and so we need to take the reciprocal of that, which will send it down to the denominator, and notice that the negative 2 becomes a positive 2. And then we look at this 5 to the negative fourth. Taking the reciprocal of that will send it to the numerator, and the negative 4 becomes a positive 4, leaving us with 5 to the fourth divided by 3 to the second. Now there are things to be cautious about when utilizing these rules. You want to make sure that you are only sending things to the reciprocals that are being raised to a negative power. So in this numerator, we have negative 7 times x to the negative third power. Now that x to the negative third power is the only thing that is receiving a negative exponent. So the negative 7, as you can see over here, should stay in the numerator while we take the reciprocal of x to the negative third, and that will bring it down to the denominator, leaving it with a positive 3. And then again, we still have this y to the negative 6 on both sides here. And so we still need to take the reciprocal of that, and that will move up into the numerator with a positive exponent now. So make sure that you aren't taking reciprocals of numbers that don't have negative exponents on them. The other rule we want to look at is negative exponents and the reciprocals. So if you ever have a quantity, such as we have here, raised to a negative exponent, what eventually will happen is you take whatever was in the numerator, and that now becomes the denominator, and vice versa. So whatever was in the denominator will be in the numerator, all raised to now the positive exponent. So if it was once negative n, it now becomes a positive n. And when doing this, you need to make sure that x and y, or the denominator and numerator, are non-zero real numbers, and n, or the exponent, is an integer. So in the example, we have x divided by 3, and that quantity raised to the negative fifth power. So if we remember the previous rule where this negative fifth needs to be distributed to both the numerator and the denominator. So we're left with x to the negative fifth divided by 3 to the negative fifth. Now looking back at changing from negative to positive exponents, we know that if we start by looking at the numerator, we need to take the reciprocal of that, which would move it down to the denominator, and make the exponent positive. So now the negative 5 becomes a positive 5. And if we do the same thing for this denominator, the reciprocal moves it into the numerator, and we're left with 3 to the positive 5th power. Now, if you write that as a quantity, utilizing that rule, you can see that you have the same powers of 5 in both the numerator and denominator. So you have the quantity of the bases, or 3 divided by x, all raised to the 5th power.